Would you like to learn about the AWS cloud storage options, specifically EBS, EFS, and S3? If so, this video is for you. In this video, we will discuss block storage, object storage, and file storage. And then we will discuss the AWS implementations of these common storage area networks. First, we will describe them, and then we will walk you through a lab on AWS S3, which is object storage, AWS EBS, which is block storage, and of course, EFS, which is AWS managed file storage. Let's begin by discussing block storage. Block storage is a type of storage area network, meaning it's accessible over a network. Now, cloud providers use block storage as it enables the decoupling of the server and the storage hardware, which promotes scalability. Traditionally, the hard drive is in the server, which is also called file storage. But the challenge is, at some point, the servers are just going to run out of hard drive space. And with block storage, because the storage is somewhere else, we can easily add additional hard drives or storage to the storage area network at any time. This enables cloud providers to have a very simple, scalable, and cost-effective solution to resell to their clients. Block storage is going to be used by virtual machines, and it's going to function as a virtual hard drive. The reason this works is in a traditional file storage, our data is broken down and stored in blocks. And the way block storage works, we have data, and it's broken down into blocks. So it's going to feel a lot like the traditional storage in the system or the computer, even though it's somewhere else on the network. So you can think of block storage in the cloud computing environment as sort of a virtual hard drive, which you attach to your virtual server. And block storage will be used by servers, whether they're web servers, application servers, database servers, or really any other kind of server. Now, on the cloud, block storage is the fastest storage we can get. But keep in mind, block storage is actually fairly slow compared to traditional server storage. For example, on a server, we can get a 19 million input and output operations RAID card for the server. But in the cloud, the fastest storage we can get is about 250,000 input and output operations per second. So you can see it's noticeably slower. All cloud providers have block storage. AWS calls theirs Elastic Block Storage. Azure calls theirs Azure Managed Disk. And Google calls theirs Persistent Disk. AWS provides 5 tiers of block storage, and we'll cover them. The first storage tier we'll talk about is EBS Provision IOPS, specifically IO2. And this is going to be the fastest and most high-performance storage on the AWS cloud. It's going to give us the most input and output operations per second, which is going to reduce the latency. And this is designed for workloads that require a lot of input and output operations. Think about a large database where you're constantly reading and writing. Relatively good for applications that require low latency, and the throughput, or the amount of data that can be moved, is relatively good on these drives, or these virtual drives, at about 4,000 megabit a second. It's close to what you would get on an NVMe drive in your computer, which is about 6,000 megabit per second. And with the IO2, we can get upwards of 250,000 input and output operations per second. So it's relatively good storage, and it's the fastest we're going to get. The next EBS version we're going to talk about is EBS Provision IOPS, but IO1 versus the last was IO2. And this is the second fastest storage option on the AWS cloud. It's relatively low latency, and it's good for workloads that have a moderate to high amount of input and output. Still good for a large database, relatively good for applications that require lower latency. We get moderate throughput on these drives at about 1,000 megabit a second, and upwards of 64,000 input and output operations per second. So it's relatively good. Next down on the list, we have EBS General Purpose SSD, also called GP2. And this is general purpose SSD storage, which gives us a relatively good balance of pricing and performance. It's great for boot volumes, as it's persistent storage, meaning it's going to stay there after a reboot or instance termination. It's got medium input and output operations per second. Not bad, but not great. It gives us moderate throughput at about 250 megabit per second, and it's good for transactional workloads, and this type of storage is excellent for development and testing environments because it gives us relatively good performance at a relatively low cost. The last 2 block storage options we're going to cover are EBS Throughput Optimized HDD. ST1, if you will. Now, this is going to be low-cost magnetic storage. Because it's magnetic, it's going to be high latency, which means low input and output operations per second. It does have some moderately decent throughput for magnetic drives at 500 megabit per second because it's coming from a RAID array, and it's designed for relatively frequently accessed workloads. Great for throughput-intensive workloads like pushing large amounts of video. It's also great when there's a lot of data to store, and low latency is not required. Think about big log storage or something where you're going to have good sequential read and writes. The last storage option we'll talk about with regards to AWS Elastic Block Storage is EBS cold HDD, otherwise known as SC1. This is going to be the lowest cost, the lowest performance in terms of input and output operations per second, relatively low throughput at 250 megabit per second, and it's good for workloads that are not going to be accessed frequently. Next, let's discuss object storage. Object storage is another type of storage area network, but in this case we have our data, and it's going to be broken down into objects. What's very unique about object storage is every object will have its own object identifier and metadata. Metadata is really data about data in the actual object. Now, this metadata provides businesses a lot of value as it helps them find the object. So think about it. You can search for parts of the data, and you can also integrate it into big data environments like data lakes because of that metadata. So object storage is going to be used in lots of big data environments. It's going to be used for backup and archival purposes, software distribution, static website hosting, and big data. Object storage is used on all cloud providers. AWS calls their storage object storage S3. Azure calls their object storage blob, and Google calls their object storage cloud storage. They're all functionally equivalent. Now, with AWS, they have different storage classes for object storage, and each has different cost structures. We have AWS S3 Standard. This is traditional object storage. You are going to use it to store information that you're going to access frequently. You basically pay a fee for the storage per amount of storage, and you can retrieve it and use the data anytime you desire at no additional cost. Next down the list, we have S3 infrequent access. Guess what? The reality is it's the same object storage as before, but the pricing structure is different. With S3 infrequent access, effectively what happens is you pay a lower fee to store your data, but you have to pay a fee to retrieve it. So S3 infrequent access is wonderful for information you're not going to use a lot of, but it's terrible if you're going to be pulling it every single day because the retrieval fees will get too expensive. So use infrequent access for information that you need readily available, but you're not going to use it very often, and you can benefit from the cheaper costs. Next on the list is S3 Intelligent Tier. And this is kind of interesting. Essentially what's going on with S3 Intelligent Tier is Amazon is monitoring your storage, and they look about how frequently you access things, and Amazon will automatically place your data in the most effective storage location. But it's automatic, and the cloud provider is in charge of moving your data around. Next, we have various forms of Glacier storage, which are really nothing more than object storage, but with lower storage costs. But they either come with a delay to retrieve your data, or there is a higher fee for the data, or if you need your data immediately, then you're going to pay a much higher fee. Glacier is used for things that you're not going to access very frequently, long-term archival purposes, so to speak. The last type of storage we will discuss is file storage. File storage is traditional storage, just like the hard drive that's inside of your PC. And it can also be accessed over a network. For example, if you've got a hard drive in your PC and you want to share it with other users on the network, that is file storage. File storage is hierarchical, and what do we mean by that? You store your data in a folder, and you can have another folder inside of a folder and another folder inside of that folder. We like to call that hierarchical storage because it can be organized in folders. Now, when it comes to file sharing, Windows systems use the server message block protocol, otherwise known as SMB, for file sharing, and Linux and Unix systems use the network file system for file sharing. All cloud providers will have a managed file sharing offering. What does manage mean? It means you don't have to set up a file server. They manage it for you. Now with AWS, they call their file storage Elastic File Storage, otherwise known as EFS. Azure calls their file storage Azure Files, and Google calls their file storage File Store. They're all pretty much functionally equivalent. AWS EFS is managed by Amazon, and realistically speaking, it's the network file system, which was invented by Sun Microsystems a long time ago, which is now owned by Oracle. Now, when it comes to the Elastic File System, otherwise known as EFS, we've got two options. We've got the standard, which is the normal and highest performance option, and we also have the infrequent access, which is lower cost for files that are not accessed frequently. Additionally, you can choose from three different performance options. You can have burstable. Now, burstable basically gives you a baseline rate and expands a little bit as needed if capacity is there for you. You can have provisioned, which is where you know exactly what your needs are going to be, and you plan ahead of time. This is going to be the highest performance, and it's going to give you guaranteed throughput. And this is going to be best when your average performance and peak performance differ by more than 5%. The last type that we'll talk about is elastic throughput, which realistically auto-adjusts up and down to meet your needs, which is great as long as there's less than a 5% difference between average and peak. If it's going to be more than 5% difference between average and peak performance, that's when you're going to want to use provision and guarantee it ahead of time. Now that you know the various types of cloud computing storage, block storage, object storage, and file storage, we will have Eddie walk you through some labs on AWS EBS, AWS EFS, and of course, AWS S3.
Hi, in this tutorial, I'm going to show you how to create an elastic block store volume and attach it to an Amazon EC2 instance. So before you create your elastic block store volume, you want to make sure that you have created an EC2 instance and SSH into that EC2 instance. So I've already SSH into my EC2 instance using git bash. And now I'm going to create my volume. So I'm going to go to the left panel and scroll down to volumes under elastic block store. Under elastic block store volumes, you're going to find a volume which has already been created. And this volume is created by default when you're creating your EC2 instance. So we're going to create a second volume and attach that volume to our EC2 instance. So you want to go to the top left, the top right, and you select create volume. Under the volume settings, you're going to start with the volume type, and you want to click the drop down and select from a list, but we're going to leave it at the general purpose SSD. For the size, we're going to change it to 10 gigabytes. And for the availability zone, we're going to select the availability zone of our EC2 instance, which is US East 1B. Again, you must make sure that you select the availability zone of your EC2 instance which should be the same as that for your volume as well. For the snapshot ID, we're going to leave it as it is and encryption as well. So we'll go ahead to create the volume. It shows that we have successfully created the volume. And now, to attach this volume to our EC2 instance, you want to click the box at the left side of the volume and you select Actions. But upon clicking Actions, you're going to find out that the option to attach the volume is still gray. It is not available. This is because immediately after creating the volume, you want to refresh the Volumes tab and you click the box and now it is available for you. So you want to click on Attach Volume, and under the instance, you're going to find beneath the box that only instances in the same availability zone as the selected volume are displayed. So if your instance is not in the same volume, which is the same availability zone as US East 1B, it won't display once you click the drop down. So you want to make sure that your instance is in the same availability zone, which is US East 1B. So you click the drop down and you're going to find our instance, which we created in the same availability zone. After that, we want to click on attach volume. Great, we have successfully attached our volume to our EC2 instance. Now we're left with one more step, which is to mount this volume to our EC2 instance, and we're going to do that using Linux commands on our SSH client. So you want to go to your SSH client. For this tutorial, I'm using git bash, and we're going to play with some commands which are going to display us various options to let us know what we can do to mount our volume to our EC2 instance. So the first command we're going to list is the df-h, which is going to list all the volumes which have already been attached to our EC2 instance. So here you can find the first volume we saw before we created the second, and this volume is attached by default when we create our EC2 instance. But yet we can't find the second volume which we've created because we haven't yet mounted it onto our EC2 instance. So to do that, we're going to go further with the second command, which is the lsblk command. And this is going to show us all the disks which are available, or the block devices which are available to mount on our instance. So we have the XVDA, which is the first block device which has already been mounted and partitioned. But yet we have the XVDF, which is the second disk, which is yet to be mounted to our EC2 instance. So we're going to verify if the XVDF disk has a file system. If not, we're going to create a file system to mount this disk to, and then mount it to our EC2 instance. So first off, we're going to start with the file-s command, which is going to verify if we have a file system on our XVDF disk. So the output shows data, which means that we currently do not have any file system on this disk, the XVDF disk. So we're going to create a file system and create a directory in which we're going to mount the device, the disk, to our EC2 instance. So we're going to create a file system by using the command mkfs-t xfs dev/xvdf. And now we have created a file system for our disk. Now we are going to create a directory in which we're going to move this disk to and mount it to our EC2 instance. So to create a directory, we're going to use the mkdir command -p. I'm going to create a directory called volume and a subdirectory called new volume. And you hit enter. Great, it has created our directory. Now we want to navigate into this directory we've just created. So we're going to use the command cd Now we're in the same directory which we created, and we're going to mount our disk onto our EC2 instance. So to mount it, we're going to use the command mount /dev/xvdf in the directory we just created, which is new volume, which is volume/new volume. Great. So now we have mounted our disk onto our EC2 instance. Now to verify if we have successfully done that, we want to input the same command we inputted earlier, which is the df-h command. And here you're going to see that we have successfully mounted our volume, which is among the list of the volumes which are all mounted on our EC2 instance. If you remember earlier, we were only able to see the dev/xvda disk, which is the first volume we created when creating our instance. But now we have the second volume which we created, which is 10 gigabytes, which has been mounted onto our EC2 instance. Now to verify from the console if we have mounted this volume, we're going to navigate to our EC2 instance. We're going to click on it, the left box. We're going to go to storage, and under block devices, we're going to find the second volume, which is 10 gigabytes, which has been successfully attached to our EC2 instance. Hi, in this tutorial I'm going to be showing you how to create an elastic file system and mounting it to two EC2 instances. To begin, we'll need to create a security group to attach to our elastic file system and to our EC2 instances. So to access security groups, you want to type EC2 in the search bar. And when you're on the EC2 management console, you want to look at the left side panel and scroll down to Network and Security. Under Network and Security, you're going to find Security Groups, and you want to click that. Under Security Groups, we'll be required to create a separate security group, which we're going to attach to our elastic file system and to our EC2 instances. So to create a new security group, you look at the top right and you're going to see the option Create Security Group. For the security group name, we're going to name it as EFS Security Group. For the description, we're going to name it as Security Group for EFS. And under the VPC, you're going to see that you have the default VPC linked to this security group by default. But in case you have a VPC already created in your environment, you can select that VPC as well. For now, we're going to use the default VPC, which is created in our AWS accounts. For inbound rules, we want to add a rule to allow SSH traffic. And for the custom source, we're going to add the 0.0.0.0/0 side-up block. For the outbound rules, we're going to leave it as it is to allow all traffic. And we're going to create security group. Great, so now we have created a security group, but we'll still need to edit the inbound rule we just created to add an NFS inbound rule to permit our file system to exchange traffic with our servers. So we're going to click on the security group we just created and proceed to the option to edit the inbound rules at the top right. So here, you're going to click on Add Rule. On the drop down, you're going to select NFS, which is going to permit traffic from the port 2049. And for the source, we're going to select the security group we just created, which is the EFS security group. After doing that, we're going to click Save. Now that we have created our security group and added the inbound rules, we're going to proceed to creating an elastic file system. And to do this, you're going to type EFS in the search bar. And once you're on the elastic file system page, you want to go to create file system. Here, we're going to give a name for our file system. I'm going to name it test file system. And it is linked to the default VPC which we have created in our AWS account, which is fine. We can go ahead and click on create. Now it is in the process of creating and it is done. So at this point, we're going to have to tweak some of the settings of our file system which we just created. And to do this, we're going to select the circle at the left side of the file system, or we can go ahead and click the name of the file system we just created to access the options. And under General, in case you want to modify any of the options, you can click on Edit, and you're going to be shown several options you can tweak based on your use case for your file system. You can have transition into infrequent access. We're going to leave it at 30 days. We're going to enable automatic backups. And for the throughput mode, we're going to leave it at enhanced, where you can select bursting as well. And we're going to leave the performance settings as elastic. Great. So now that we are at this page, we want to go to the network tab, where we're going to be adding where we're going to be managing the security groups which are linked to our EFS or elastic file system. Equally, we're going to be limiting the availability zones to just 2 for the purpose of this tutorial. So to do this, you're going to click on Manage at the top right. Once you're under Manage, you want to remove all the other availability zones apart from US East 1B and US East 1A. Again, this is just for the purpose of this tutorial, but you can leave it as it is, or based on your use case, you can use all the availability zones. But for the purpose of this tutorial, we're going to do just 2. So I'm going to remove US East 1C, US East 1D, US East 1E, US East 1F. At this point, we're going to specify the security group we want to attach to this EFS, or to these availability zones. So to do that, you're going to click the drop down, and you want to scroll to the name of the security group which we just created. So here it is, EFS security group. You want to click that. And here, we want to click the same security group which we just created. And we can go ahead and click Save. So now we see that we're having only 2 availability zones attached to our Elastic file system. Now we want to go to the EC2 instance tab to create EC2 instances which we're going to use for attaching our Elastic file system. So to do this, you're going to go to the EFS, to the search bar, and you type in EC2. Once you're here, you want to go to Launch Instance. And we're going to provide a name for our EC2 instance. We're going to name it as Test Server 1. We're going to leave it as Amazon Linux machine image, free tier eligible. For the instance type, we're going to leave it at T2 micro, which is equally free tier eligible. And for key pair login, we're going to use proceed without a key pair, which is not recommended. But for the purpose of this tutorial, we're going to be using the browser-based we're going to be using the browser-based command line to access our EC2 instances or EC2 Instance Connect. Under network settings, we're going to tweak these settings to allow traffic from our security group which we just created and attaching our Elastic file system. So to do this, we're going to click on Edit, and we're going to select a subnet which is among the list of the target groups we selected for our Elastic file system. So we're going to select either from US East 1B or US East 1A. I'm going to select US East 1B. For the auto assign public IP, we're going to leave it as enable. Under firewalls, we're going to select existing security group, and from the drop down, we're going to select our security group which we created, EFS security group. We're going to leave the advanced network configuration as it is. And under configure storage, we're going to attach our Elastic file system. So to do this, we're going to click on Edit, and we're going to click on Add Shared File System. So by default, it has selected our test file system which we just created. For the mount point, for the purpose of this tutorial, we're going to change it to /demo. Which is the directory in which the EFS is going to be mounted onto the EC2 instance. We're going to disable automatically create and attach security groups because we have already created one manually. And we're going to leave the option automatically mount shared file system by attaching require user data script as checked. At this point, we're going to create 2 EC2 instances just to test how the Elastic file system works, and we're going to click launch instance. So currently our EC2 instances are in pending state. We want to be patient for a while they launch. Then we'll proceed to connect to them. Great, now they are currently running. So we want to connect to each of these EC2 instances using EC2 Instance Connect. So to do that, you're going to click on one of the servers and select Connect. On the Connect tab, you're going to select EC2 Instance Connect and you're going to go to Connect. After clicking Connect, you'll be redirected to the EC2 Instance Connect tab. Great, and now we are connected to our EC2 instance. Now we're going to be test running some scripts to see how exactly the Elastic file system works. So the first command we're going to do is to navigate to the file directory we created for mounting our EFS. So we're going to change the directory to demo, cd/demo. Once we're in the demo directory, we want to try to create a file which we'll be able to access from our second EC2 instance, as we're going to see subsequently. So to do that, we're going to type in the command sudo touch/demo/test.txt. Now to list the files which we have currently created in this directory, we're going to type in ls. And we're going to see that the test.txt file is currently in this directory. To test this file being accessed on the other EC2 instance, we're going to go back to our EC2 instances and we're going to select the second instance and connect to it as well using EC2 Instance Connect. So here we're going to change the directory to our demo directory. We're going to list the files which are in this demo directory. And there, we're having the same test.txt file which we created in the first EC2 instance here, which is available in our second EC2 instance to show that this file is being shared across two EC2 instances. At this point, we have successfully created an Elastic file system. We created a security group to attach to allow inbound traffic to our servers, and we created an Elastic file system to attach to both our EC2 instances, and we were able to create a file which we could access from both EC2 instances. Thank you. Hi, today I'm going to be showing you how to create an S3 bucket on AWS. To begin, once you're logged into your free tier account, you want to go to the search bar and you type in S3. After you type in S3, you're going to be presented with a list, and you want to select the first option at the top, which is scalable storage in the cloud. You'll be redirected to the S3 management console. And once you're there, you want to go to the top right and select Create Bucket. Great. So now we're under the options to customize our S3 bucket. So we want to start by providing a bucket name, and take note that the bucket name must be unique according to the bucket naming rules, which you'll find in the link directly below the box. So you click on See Rules for bucket naming. After you click on it, you're redirected to a page which is going to show you all the rules to be mindful about when creating an S3 bucket name. So you just see, for example, bucket names must be between 3 minimum and 63 maximum characters long. Bucket names must begin and end with a letter or number, and so on and so forth. So after you've reviewed these rules, you want to go back and provide a name. So for the purpose of this tutorial, I'm going to provide the name GCC test bucket 123. In case this name already exists and is associated with the bucket which already exists in AWS, they are going to prompt you when you're about to create this bucket, so you can modify the name or make changes where you see fit. Under the bucket name, you can select an AWS region where you want this bucket to reside. You have US East, US West, but I'm going to leave it at US East North Virginia. Under object ownership, you want to leave ACLs disabled, and you want to ensure that you have block public access enabled for your bucket. And for versioning, this is a feature which permits you to replicate the objects you upload to your bucket for high availability and to ensure that you don't accidentally delete a resource in your bucket which is critical. So this is just a measure to prevent accidental deletion and to secure the resources you upload to your S3 bucket. We can leave it as disabled. For tags, we can leave them as empty. And for default encryption, we can leave it as server-side encryption with Amazon S3 managed keys. You can go ahead and click Create Bucket. Nice. It shows that we have successfully created our bucket. So we can go ahead and start uploading resources into our bucket to see how exactly the S3 bucket works. So to do that, we're going to click on the bucket name for the bucket we just created, and we're going to be redirected to the management page for our bucket, and you want to click upload, which is at the top left. So after you click upload, you can drag and drop the files you want to upload, but in case you are not able to drag and drop them, you can click on add files. So I'm going to click add files, and I'm going to upload a file I just created. And take note that after adding the file, it doesn't upload automatically. You have to scroll down and select upload from the bottom. So after you click upload, it's going to show you the upload progress. And when it's done, you're going to see upload succeeded. So at this point, we have successfully uploaded a file to our S3 bucket. Great. At this point, you can create a folder and give it a name. I'm going to name this folder 1. And we can move this file into our folder, as well as we can open this folder and create other files and upload other files into our S3 bucket folder. So in case we wanted to delete our S3 bucket, how do we go about that? We want to go back to buckets, and you want to click on the option, the name of the bucket you created, and you want to click on delete. So it's going to show you that the bucket is not empty. This means that we have to empty the bucket before we can delete the bucket itself. So once you go back to our buckets, once you click on the bucket name, I want to click on empty. So to permanently delete all objects in the bucket, you are going to be required to type in the name of the bucket you created, or you type in permanently delete. So I'm going to type in permanently delete. And I click empty. So it has deleted the file we just uploaded and the folder we created. So we can go back to our bucket to delete it. So I'm going to go back to buckets. I'm going to click on bucket and I'm going to click delete. So to confirm deletion, you have to enter the name of the bucket in the field below. So I'm going to type this name. I can just copy it and paste and select delete bucket. There, we have successfully created an S3 bucket on AWS. We have uploaded a file into our S3 bucket and we have created a folder. We deleted the file and the folder we uploaded, and we ended up being able to delete our S3 bucket. Thank you very much for watching this video, and we hope to see you again. Thank you.
We hope you've enjoyed this discussion on EBS, EFS, and S3. To learn how to become the ultimate cloud architect, or how to get your first cloud architect job, or how to get promoted in tech, please attend one of our free webinars. The links for these free webinars are in the description below. Also in the description below, we have a tremendous number of free resources to help you with your cloud architect career. Lastly, please like this video and subscribe to this channel, and make sure to hit the bell to be notified of new videos to help you in your cloud architect or tech career. I look forward to seeing you in another video.